Hi everyone, my name is Rebecca Ha, and I'm an assistant electrical engineer at Burns& McDonnell. And on behalf of Burns& McDonnell, I would like to persuade you to fully understand the benefits of using VR, AR, and MR technologies and urge you to consider implementing these modes of technology into the company's engineering design process. Now, what does VR, AR, and MR stand for exactly? Well, VR stands for virtual reality, AR stands for augmented reality, and MR stands for mixed reality. Now, I pursued this research to provide a transformative method for creating engineering designs for employee use that will open endless opportunities for both Burns McDonnell and its clients with the use of VR, AR, and MR technologies. Now, how did I come about choosing this topic to do research on? Well, I have been interning with Burns McDonnell since the fall of 2018, and I had the honor and pleasure of getting to work with an individual named Charlie Cox. Charlie Cox is an application specialist at Burns McDonnell who specializes specifically in VR and AR technologies. And he would take a lot of the new hires and interns like myself down to the VR lab and kind of show us how we can use AR and VR technologies in engineering work and how transformative it is. And from those experiences, I learned and realized that more and more companies will be implementing VR, AR, and MR technologies. So as a very top tier engineering firm, such as Burns McDonnell, it's very important that we plan for the future and kind of ride the trend as well and really become a titan in the industry of VR, AR, and MR technologies. So in today's discussion, here's kind of a layout of everything I will be talking about. I will be reporting all of my research that I've been doing. I will introduce first the topic, provide key features and functions, a detailed analysis, a conclusion, and end with an audience Q&A forum. Now, let me first start by introducing the purpose of this topic first. Now, as Burns McDonnell, to maintain our position as 9th in top 500 design firms, we must deliver on our mission of emphasizing safety and ownership, meanwhile transforming the engineering design process, because in fact we are an engineering firm. Burns & McDonnell is committed to providing the best quality work, and we will uphold this commitment and mission by implementing VR, AR, and MR technologies for the benefits of the company, its employees, and its clients. Thus, I recommend that Burns & McDonnell implements VR, AR, and MR technologies in the engineering design process for project work. So today, I would like to persuade you to fully understand the benefits of utilizing VR, AR, and MR technologies and urge you to consider implementing these modes of technology into the company's engineering design process. Now, let me first discuss the key function features of implementing and utilizing VR, AR, and MR technologies for engineering projects that will lead to extraordinary improvements. Now, here are the list of the improvements that will greatly benefit Burns McDonnell as a company and as a business, and also help our employees be happier and our clients also be more satisfied with our work. So these improvements include project quality, employee efficiency, employee-client collaboration, and reduced costs associated with reconstruction. So there are three main takeaways to consider for implementation, and three key features are VR, AR, and MR technologies, each mode of technology. So the first is VR. A study published on advances in computer science research showed that VR has made a tremendous impact on industrial designs, providing engineers with more intuitive ways to produce new ideas. So next is AR. AR technology is continuing to transform the digital game. There are a number of applications that are being used today, including very popular social media apps, such as Snapchat and Instagram. And finally, there's MR, which was thought of being the next wave in computing. It's a blend of both the physical and digital world, unlocking 3D human, computer, and environment interactions. So to represent the distinctions and similarities between VR, AR, and MR technologies, a diagram here is shown to help both engineers and product development executives understand the different features that are offered by each mode and decide upon either one or all combinations. So virtual reality is exactly that. It is where it's a fully artificial environment. Augmented reality is where if you were to look at the table next to you or in the room with you, virtual reality or augmented reality is where a virtual ball will be bouncing on that actual table in the lens that you are looking through. And then mixed reality is kind of a combination between virtual reality and augmented reality. So after doing extensive research and comparison analysis, I've concluded on a recommendation that I believe is the best option: wearable augmented reality headsets. I've been speaking to Charlie Cox about this and kind of what he also thinks as an application specialist in this area, and he also agrees that wearable augmented reality headsets would be the most beneficial and be the best kind of like happy medium for the company, the employees, and our clients. So after careful research and evaluation, it's recommended, that wearable augmented reality headsets are utilized due to the superiority and of the features included in every one of its categories. And there are also added benefits of allowing users to experience both real and digital worlds. Shown in this figure is a diagram showing the step-by-step process of a DigiLens diffractive waveguide that displays how light and images are visually projected to the human eye. Now, this diagram would show how a wearable augmented reality headset would work and how it acts as an augmented reality headset. And as we can see, we see the processes it takes, and like I said, augmented reality headsets are truly the happy medium for everyone, and they are highly recommended by me and my colleague Charlie Cox. Now that I've covered the key features provided by VR, AR, and MR technologies, I will begin presenting a detailed analysis of these technologies. So, diving in, VR, AR, and MR technologies can be applied to client project work, increase efficiency of time and resources spent on them. And with all of this in my analysis, I will be providing a benefit and drawback analysis and comparison that I will be covering in the following slides. So there are many benefits that are associated with VR, AR, and MR technologies that are truly beneficial from a business and company standpoint. The first one being that it allows engineers to design a 3D object in a 2D environment, which increases accuracy tremendously from the employee's standpoint and engineering standpoint. The interactive features of VR allow engineers to engage in meaningful creative designs, and organizations utilizing it are noticing that more engaged employees are more engaged and an increase in productivity and there are lower travel expenses. So here we can see that there's a benefit greatly for the employees and also greatly for the company. And so when the company and the employees are benefiting and becoming more efficient, clients will roll in naturally and automatically, pretty much. So this bar graph here depicts an experiment conducted by the Department of Computer Science and Engineering at Qatar University. Their students were given a task of designing a kitchen for handicapped people in wheelchairs. So these students were split into two groups, one with the ability to use a VR approach and come up with a solution, and one without. So after completing the process of designing a kitchen model for handicapped people, both groups of students gave their responses on their experiences. Now shown here, it's evident in these responses that the students who use a VR-based approach had significantly better communication processes, higher scores in learning outcomes, in engineering design, and an improved ability to problem solve. Now, although the benefits outweigh the drawbacks, it's important to discuss the drawbacks as well. One of these drawbacks includes not being able to predict how much a VR/AR app development will cost, since there's such a wide range of financial values. There's also an issue with exporting and importing libraries in the current BIM workflow, since some design information can be lost in the process of that transfer. However, with time and familiarity and practice, these drawbacks will hold less value and no longer hinder the VR/AR MR design process. So in conclusion, I've introduced the purpose of the topic, outlined both the key features and function, and an analysis of using these technologies. My research is worth pursuing and implementing, and it's shown that there are more companies that are implementing these technologies, so it's imperative that today we get on board and we begin implementing these technologies. And I have persuaded you to fully understand the benefits of using VR, AR, and MR technologies, and urge you to consider implementing these modes of technology into the company's design and engineering process for all of the benefits that it will provide to the company, the employees, and also our clients. Thank you for listening to my presentation. Are there any questions?